Good morning, everybody. I want you all to hold your hands. No, we came up with a new one. Whose name is facing forward? Whose name is facing backward? Raise your hands. It's 50-50. It doesn't mean you're special or not. So today we're going to talk about what we do for a living, what I do for a living, facility condition assessment, innovation, and justifiable capital plans. There's a lot of words. We're going to focus on kind of how condition assessments lead to a capital plan and discuss issues of scope and scale. I'm going to focus on kind of lessons we learned from a big project that we've done over many years. And everybody's talking about BIM and innovation, so I'm going to bring in innovation. I am Steve Warshaw. I'm the CEO and founder. And as you heard, I'm actually an engineer or applied scientist by training. We have been in business for over 20 years doing this. Me and early founders mostly come from kind of engineers who like to code, and that's what I am. I was trained to be a structural engineer working at NASA. NASA was downsizing when I came out of school, and here I am doing software for facilities. We're really a software company, so we focus on cutting edge tools, and we've been recognized both as for customer service. We deal with kind of a pretty complex workflow that requires us to interact with people in a pretty heavy way. So customer service is very important to us. Our product has been received awards. We have diversity awards. We're pretty proud of it. For me, this is really a credibility slide. You don't know me. So going beyond that on the credibility side, and not just for us, but also as the approach. We have been involved recently in over $50 billion of capital plans, hundreds of thousands of inspections, thousands of sites, hundreds of millions of square feet being inspected and planned for. Let me talk about the case study that we're gonna talk about today. So this is something that we've done for a long time. It's the New York City School Condition Assessment and Capital Plan. It's a pretty large endeavor. It serves over 1 million students. They have more than 1,500 schools and the buildings that go with that, more than 1,500 buildings. Their 5-year capital budget is over $15 billion, and their annual capital plan average is about $4 billion. So that's kind of new construction, not including maintenance. So it's pretty big. It's diverse in many ways. So the buildings are diverse. They've been built in different years. They're in different neighborhoods. They serve different types of students. Some places the constituents are extremely involved. Some places they're not. The stakeholders are pretty diverse, all the way from the governor to the principal to the parent. Yeah, and when we talk about scale, obviously it's large in scale, but it's also very local in scale. So there's people who care about their school, and they don't really care about anything else. So it kind of has to work for one as much as it works for the thousands. So that's an important aspect. As we did this, as we implemented this from scratch and kind of where we arrived at today, we ended up working with the school system to break down their process into 4 steps. And this kind of helps us think about how we go through this condition assessment and capital plan. And it didn't start like this. This kind of evolved over years. But let me just identify the steps, and then we could go and focus on kind of what's unique in each one of these steps. Before I move forward, I have to do a survey. And I just want to get a quick sense of how many of you have like an automated end-to-end system for capital planning and the condition assessment. Does anybody here do this end-to-end? Excellent. So 1. I actually thought it would be more than 1, but that's good. That's good. How many of you are doing this at all, like produce a capital plan? Oh, that must be a timed slide. How many of you have a capital plan statement that the institution has? How many of it do it in Excel? How many of you have an external consultant who does it for you? Oh yeah, interesting. So here's how we think about it. It's not that complicated. We do an assessment. So we look at the facilities, we come up with the condition, and what that means we'll talk about. We then take that data, analyze it, and come out of that from a statement of need. And when I think of a statement of need, it's saying, this little thing that I saw was broken, I need to fix it, this is how much it costs. From a condition perspective, right? So we think of those as needs. Condition is not really a need, it just says how it is. A need says this is what it's going to take to fix it from a financial perspective. And you can think about needs going beyond that. It's not just to fix the condition, this is what I need. You have other needs. You have increased enrollment. You have decreased enrollment. You have a mission to increase sustainability. So there's other kinds of needs, that's what you consider. And at the end of the analyze phase, you end up with a statement of need. And that could be a financial statement of need, but it could also be a list of things that have to happen. And that's actually both. The next thing is, and some people stop there, and there's an issue with stopping there, and we're going to talk about that later on. The next thing is to take all these needs and say, what am I going to do about them and when? So even though I think of the statement of needs as already prioritized and costed, it's not really how you do all your work. In other words, all the work that's going to happen to correct these conditions over time is going to be in some form of projects. So how do you figure out which projects you're actually going to do to meet these needs? And that's what the next step is packaging all those needs into the separate projects. And when I say a project, I mean something that could be bid out or something that can be executed that has a beginning, an end, a cost, a distribution of cost over time. Once we do that, we then forecast. We say, when are we going to do the projects? How do we spread it out over time? How do we balance our budget or how do we balance the work to form the budget? So these are the 4 steps. Assess, analyze, package, forecast. That's not the end. You end up with a plan that says what you're going to do over time and how you're going to spend your money, but now there's actually, you come back in a cycle and you might analyze your condition on some frequency, let's say annual or every 5 years. So you have another cycle that goes back, and so you will update your forecast, update your needs, update your projects, maybe change which projects you were planning to do. So that's one cycle going all the way back to the beginning. And there's another cycle is as you're managing and you're running those projects, you might actually change what those projects are. When you estimated those costs, you might refresh your cost as you're in execution, especially if it's a multi-year project and you're building something big, your estimates will change, your schedule will change. And so those 2 cycles are constantly happening to have a constant, justifiable, up-to-date capital plan. And imagine that it was up-to-date on a daily basis. And when we did this with the school system, they ended up with a system that is up-to-date on a daily basis. It's reforecasted financially and schedule amazingly, daily. They could look at it. And we're going to talk about that. So when we started doing this, both as a company and as a client, we had a few challenges we wanted to make sure that we addressed that are not trivial. I mean, one could come up with a capital plan and very simplistically come up with it, right? People do this now. People are running capital projects, so they have some form of plan. But we started looking about what it's going to take to make an automatic, automated, large-scale, that could scale down, capital plan and condition assessment. So let's talk about the first one, because this leads into most of our solutions. But if you solve for these, you solve for what we did. Points of view, different stakeholders. From this plan has to have a public face. They actually publish this plan, so it has people who are the principals in the schools, the parents, have to be able to look at it. But so does the CFO of the organization. Those are different points of view. Those are examples. The inspector who's going out in the field has to have a point of view that's much more detailed. It somehow has to translate between all these all the time. We talked a little bit about scale, but a little more. It has to work locally, globally. It has to be able to zoom in and zoom out from a point of view. The inspector is looking at flashing on the roof. The project that's being executed maybe needs to know that it's connected to it, but they just need to know that there's a roof project. So it needs to look at that. Integrations from a software point of view, the plan has to consider information from a lot of other systems, the financial systems to update So when I say the financial systems, like the ERP of the organization that says how much money you paid each vendor that's doing the contract is an input into the system because you have to figure out from that how much you have left to spend. Right? The project management systems that are actually running the projects. If you have a system a GIS system that says where your facilities are, needs to be integrated. And we know that we're not going to do all these systems, right? These are in place. So integration solving for all those integrations is an important aspect of what we do. Agility to me means be changing and improving all the time. Just when they talk about agile programming and software is something that we exercise, it means at short frequencies, refine your methodology and adjust your policy. So you need to have these knobs on the systems that you could adjust. And we'll talk about those. And objectivity, you need from year to year to be looking at things the same way, different inspectors looking at different places to be comparable. If you have a lot of facilities and you want to prioritize between them, apples to apples has to be an important aspect of what you do. So, with all these in mind, you have to find something that will actually fit this situation. And the fixes that we see that don't always work are things where they don't consider all these things, right? Where they're looking at the short term. And I won't belabor the point on that. So now let's dive in. But before we dive in, does anybody have any questions on the big approach? Because it's not a big room, we have time. Okay, let's just dive in. So assess. When we do an assessment, the first step is to consider if you're doing assessments now, and you're doing paper, or you're just collecting information from people there, the challenges you have, like the state you're in, is you don't have a standardized language, which makes it hard to evaluate. You can't really look for changes over time because you didn't do it consistently over time. And even if you did, it might not be able to look at it in a consistent way. If you're doing field work to do all this stuff, you don't have an easy way to manage that field work, especially at scale. If you have to go and do thousands of inspections, how do you know, and they're filling out forms on paper, how do you know that they were all filled out correctly? And you're going to end up with not having the right information all the time, if it's not automated, right, if you're doing it on paper. Even if you're doing it on iPads or laptops or Excel, if you don't have a system that's good for it, you're going to have these issues. So, it doesn't seem like that big a deal if you think about how you would do it with an automated system, which would be iPads or databases. But the things you have to do to end up with a universal methodology. And so to me, methodology means you have the right list of components, all your school names are right, all your locations are right, all the observations that you might make come from a list, all your deficiencies are from a unique list, all your unit costs are organized and categorized. You end up with the ability, the tool has to make sure that in the field, people, when they do the inspection, they do it in an organized way that brings up the right data. They can't leave the field, or they can't finish the inspection without filling out the right things. You can't just rely on training and manuals to say we're going to get the right information. Accountability and quality assurance are outcomes, as is you have data that you could look at any point in time and compare. So what do you get out of this? And these are not trivial. We talked about justifiable capital plan. So traceability is one of the important things for a justifiable capital plan. So if you have a project that says you should do it at a certain time, at a certain place, having the ability to trace that back to the observation that was made in the field, very important. You get that. You get traceability. You get the ability to do this work in a cost-effective way. And there's a lot of, it's not necessarily that you could do with less people. With the same amount of people, you could do a lot more. So you actually could get quicker cycles. Some places that maybe are doing this once every 5 years could start doing this once every year and get much better pictures, which makes it much more reliable. You could do things quickly. I mean, in this case, they now run an annual inspection of all buildings, all systems, and they do it in about 7 months. with probably inspectors in the field, less than 50. So it's with some support in the office. And it's a pretty big effort. And it's, when you do it right and you organize your information right, your reports are accurate. So this is let's talk a little bit about the tool they use in the field to enforce this. So the first thing is put a tool in the hands of the people making the assessment in the field. And it has to have certain features that makes it useful. So the first thing is it has to have built in that methodology. When I say that methodology, I mean all the components you might observe, all the deficiencies you might observe. Now that's about 10,000 line items, not trainable. Cannot train people to remember 10,000 items. So it has to guide you to the right things. So it's very important that it's guided and it's not sequential. And what does that mean? It means it doesn't force you to look at a facility in a certain order. You can jump around, move around, at the same time know what you missed, know what you have to fill in. So I have the tool here. If you want to see it, we could dive more into it. It's important to be able to locate things on a drawing, in the plan view or an elevation view, or as things are happening now on a BIM diagram, on a 3D diagram. It's important to be able to take photos, but you can't be correlating those later, and all should be embedded. Take it at the time you have made the observation, it's all connected. Lots of other features in terms of in-the-field quality checks that make sure that what you said makes sense. When I say what you said, I mean what the inspector said. And this became a very important thing for reaching those efficiency goals that the customer had. And we did this over time, improving on the validation checks and all those different features. On the left, you could see the view on the iPad. On the right, it could produce a PDF real time in the field or back in the office as soon as the inspector does it. So there's people there's kind of like leadership, quality leadership in the back office looking at it, and the system is also comparing information for quality. So this is important because you get good stuff. You get good data, which means you can make good decisions. This is a back office view or a management view where you have each inspection, when it happened, who did it, who edited it, what the quality is of it. And when I say the quality, is it just something the field inspector looked at, or did a quality supervisor look at it and make sure it's okay? So all those kind of controls are in there. Another thing that's important, not everywhere, but in all the, if you're doing condition assessment and you're dealing not just with your facilities, but with your grounds on your campus, to be able to describe where they have on the map and it to become immediately GIS Elbow. I don't know if that's a word. I just made it up. So on the iPad to be able to say, here it is. There's some, when you integrate GIS, there's challenges, which I'm not going to talk about a lot, but what we've figured out that the main advantages we got out of doing this is that when you have campuses with similar facilities on them, people will sometimes describe the wrong facility with the wrong name. Does that make sense? So if you have, N will describe stuff that's actually outside the area that they were supposed to be looking at. So we use geofences and maps and some of the challenges there are also, the system has to be able to work when they don't have Wi-Fi. So how do you deal with maps when you don't have Wi-Fi and all those little challenges? It has to deal with those. Now, this is an innovation slide. We just started doing this. This project just is starting to touch on this. But on another case study, not in the schools, we did roof thermographies of all the facilities. We did about 2,500 roof thermographies. Because it was so many, we got to fly not drones, but actually real aircraft to do it. We were the consumer of the data. I didn't actually fly the planes, but it was very useful. And if you start combining roof thermographies with slim BIM, which is these rudimentary BIM that's just good enough to do analysis, but doesn't have to have all the pain of creating it, then you get some really cool information. That's the slide on the right. That's actually, we overlaid the the roof thermographies, and if anybody has questions about how you do them, they're a very cost-effective way to find any kind of water issues or roof issues. On the left is a slide where when people are describing an observation, they actually put it directly on the 3D model, and we'll talk about why that's important. But that's pretty new. So we have a condition. We know we looked at all of our buildings, we looked at all of our grounds, we know what it is. Now we have to turn that into needs, and we have to start analyzing the information. So that's step 2. I'm going to dive into that step. The first thing you have to do is generate cost. And the reason I have a car there is because I'm going to make a reference to the blue book where you get the prices of cars, and everybody could take their car and look what that blue book says. It would inevitably be wrong, right? Because it's not your car. But we're just not taking that price. We actually looked at our facility. So we could come up with a much better price. So what we do is we look at a variety of variables, but the important thing is that every observation at the component type, and what component type could be a part of the flashing of the roof, look at the deficiency on that. I don't know what would be an example, but let's say there's a crack. What type of action would be on that? What that would cost per some unit of measure, let's say per square foot or per linear foot, right? So we have about 10,000 different individual unit costs that together we build up these pricing. And we look at other things like not only the material, but where it is, how old it is to come up with a price and a likely priority. And we do an automatic creation of what we call costed actions. So costed actions are the things that will, for each observed deficiency, there's a thing that says to fix that thing will cost this much. So this is our first pass at cost. And we prioritize them based on the component priority, based on, when I say component priority, a roof is more important than the sprinklers, right? Simple stuff like that, but also what was observed by the person out in the field. They give some sense, they give a 1 through 5 in terms of condition. They also try to describe when they think the thing should be fixed, based on just their knowledge. Now, when we talk about innovation, okay, so we did that, we have all the condition. When we look at that, wouldn't it be nice if you could look at your condition in a view like this? You would know right away what's going on. So this is pretty new. You would have to have some kind of slim BIM to be able to do this, but you would now be able to think about and prioritize, and more importantly, I think, communicate to the people who are going to decide the funding where things should happen. The other thing that you can do at this stage, which is to start bringing in other data. So here what we did is we took a slim BIM, we kind of like stripped out all the not important information. We put the roof thermography, which red on the roof means there's probably water inside. And then we integrated data from the CMMS system. And we started taking on work orders. And we said, let's take all the moisture-related work orders and plotted them. And you could still not tell what's going on, right? But but you can. And so if you take this model, move it around, and do some analysis, we found out, in this case, that there was a tiny little leak on the roof that was causing work orders. In that column below it, as you would imagine, you could see the plume, it like starts spreading down over years. And you can see if they just fixed that little tiny thing on the roof, which they didn't even know about, they would not have had to do any of those work orders. Now imagine how that savings kind of translates over years. And if you want, it's not part of my presentation, but it just shows the power of a slim BIM. And so this BIM is not really a model of the whole building, but it enables you to get enough so you could start correlating. Just like we do with Google Maps, tell where things are. You can start telling where things are, connecting your condition, your roof thermography, and your work orders, and you could probably have significant amount of savings in the work you're doing. That's really exciting. That's pretty new. Okay, you figured out everything you need to do. You start packaging it into projects now, right? You're getting it more onto the capital construction execution side. You're beyond the statement of need. We think about it in kind of a few more granular steps, but so we're going to create potential projects. The reason I call them potential projects is we're not necessarily going to do them all, right? And we actually, because we're doing it automatically, and you don't have to have somebody scope or do any, there's no manual work required to create a project that is scheduled and has cash flow and knows when the milestones are. Imagine you were in that world. You could create all the possible projects that you might ever have to create. And in this case, with the school system, even though in a 5-year period they run about 5,000 projects, which is huge, we generate 30,000 projects. Because what we could do then is we could start doing scenarios and say, what if we do these projects? How much would it cost? How would it affect us? So that's the first thing we do. It's automatic project creation. Okay. Now, what do you get out of automatic project creation? You end up projects, they know their scope, because they were addressing needs, and we know the needs, and we have rules that determine the scope, so we're addressing needs, so we basically know our scope. We also know our policies. How do we do construction? Like, we don't just fix one little thing on a roof. We have some threshold before we'll do a roof project, for instance, and we might look at the warranty on the roof before we do it and things like that. So we have some policy in creating these, and you end up with a cost for the project, but not just the cost for the project. You have a schedule of the cost and a schedule of the milestones. So when I say a schedule for the cost, you know that you're going to pay for a designer at some point. Then when they finish and you bid it out, you're going to probably pay some money up front, and then you're going to have some contingency payment afterwards. So we actually do a cash flow for each of those thousands of projects because it's free at this point. And we have a relative priority of the projects and when they should happen because we have the relative priority of the needs, and you add in the policy of when you're going to do things, we end up with a lot of projects. Okay. So, and this is how we do automatic project creation. We have a bunch of project templates that know their general schedule. We have a bunch of spending. We basically have 3 schedule phases: scope, design, and construction. Right? But then we have other spending phases, and we have many of these templates. Some of them are what's called start commit, which means all the money on the phase is paid on the beginning of the phase up front. And then we also have distributed spending. So if contingency, for instance, if you have a multi-year project and you have contingency spending, it's going to be weighted towards the end. So we have the ability to do that. We also have what we call soft cost factors, which know that if you came up with a construction cost, here's what you're going to have to probably pay for scope, for CM, and all those other things. So we have a whole bunch of these templates, and we know how we convert each need into one of these templates, so we just run it, we let it run. It's pretty cool. Okay, so now we have 30,000 projects. How do we make that into a plan that will be, this is real. Every year we end up with 30,000 projects. What do you do with that? You have to forecast it. So now we go into the first thing we do is we look at our horizon, and their horizon by the school system's horizon, it's actually legislated to be a 5-year look ahead. So we didn't have a lot of choice on how long. Although we do a 10-year view. The truth is because it's not required, some years they care about it, some years they don't. Okay, right? That's just the way things are. But so the 5-year view is very important, and we basically choose all the projects we're going to do in the 5 years. There also is a requirement that for the next 2 years, each project is public. It says when it's going to happen and what the scope is. So those projects in the first 2 years, like we kind of have to set in stone, because once those get printed out and put on the websites, and they change, people really care. If they're in their constituency, it's not going to happen. So the first thing we do is come up with the 5 years, and then we start distributing, and our plan ends up being which will happen when. Over those 5 years. We don't really bother after 5 years. We just put them all in the 6th year. So the 6th year looks crazy if we don't, but they don't publish it, so it's not really important. So that's what we do there. And what you end up is, after your project selection is driven by your policies, and some of the way policy is driven is by having target budgets for your different types of spending. So whether you have a budget, you might have, and you have, policy it's an external input. It could come from, like they had in the recent years, they've decided that they're going to do free 3K. 3K, it's before pre-K. It's for 3-year-olds. It's pretty awesome, right? They're rolling out in New York City, free 3K, and it's rolling out over multiple years. So they set budgets for how many, and that's new construction, or that's like leasing new places on top of kind of condition-based innovation. So they would set a budget, and that drives what you would do when. So that's an example. We also are, allocations is a way of saying, there's things we don't know what are going to happen, and you have to put money aside for those things so that they're not allocated to a project. But from running this over the years, you end up knowing how much money you're likely to need. So the allocations actually get more and more accurate every year if you run this system. The capacity projects, 3K is an example, but part of the information that we integrate is population studies and enrollment predictions, both increasing and decreasing. So we have kind of what I call them non-condition-based needs, right? It comes from other concerns, and population studies and enrollment studies are a great feeder into this. And we end up with timed projects. This because it's agile and it kind of like turns on itself, it actually would change it could change the budgets. I mean, you start with what you want the budgets to be, you take your priorities, you put all these projects in and you let them lay where they will by a year, right? And then you say, wow, I'm not addressing some needs that were pretty high priority, and then you change your budgets and rerun it. And you can run multiple scenarios on priorities because the computer's doing it and it's really not expensive. This process where they manage all this is run by a department of about 15 or 20 people whose main job is actually going and presenting this to the public all the time. So really, there's a lot of, the computer is doing a lot in this case. So here we are, we have a plan. It has all this granular data, it knows everything inside the plan, but that does nothing, that's inside the computer, right? Now we're dealing with, but it is justifiable. It has a high level of credibility. In this case, they've had multiple times thrown auditors at it from these famous, PwC and KPMG and all those 3- and 4-letter name firms, and they could ask about how each one of the steps happen, and because the computer's doing it, it actually is. They could say, oh yes, that works, or they might make a small recommendation. Ironically, what they end up saying is like, oh, that's your policy. Every time you change your policy, just decide who authorized the policy change. And a policy change in this case is represented by a bunch of numbers, basically, by data that drives policy. So let's talk about our constituents. So let's look. This is one of my most cryptic boards I ever show, but it's highly used, ironically. Why? Because the director of capital planning, this is their scoreboard. This is where they have and they know all the codes by heart. I know 1E1 means roofs, but you wouldn't know that, right? But they live in these codes, right? Because they need to make specific distinctions on budget line items, and we have the by-year spend. This changes more frequently than daily, and at some point has to be locked down. Why? Because we actually only integrate financial and schedule information daily, but there actually are people that are tweaking projects because they know something, they've decided, oh, this one project, we really can't do it, let's move it out. This project, some legislator really cares about it, move it in, right? So this is changing all the time. So looks boring, but actually highly used, and it's one point of view, very aggregated from the details. This is a report that actually goes to the public. It's a PDF, which I prefer they would make it not, but change happens over time. But if you look at it, they don't even know this, but this language right here, it says exterior, awnings and canopies. That is the same language that the inspector, when he looks at what he's doing, that's the same language. This is the same language that goes to the public. He looks at more detail. He just doesn't look at the awnings and canopies. He has sub-components and he has deficiencies, but it gets rolled up. And this is a direct roll-up of their information. It says in what fiscal year it's going to happen, right? We have more detail. We actually know what day, what month it's going to start. This actually, by definition, is the start date of construction, but that's a policy decision, right? That's on this report. And this is the cost. And the cost, not only does it say how much it's going to cost in total, of it considered inside the computer, if it happens 2 years out, what inflation is going to do to that cost. It also takes some consideration of further deterioration based on kind of regression analysis of what it takes for the components involved if you don't do anything, right? So it's a lot of pretty cool stuff in there. It also is affected by the Office of Management Budget rules on what you're allowed to do with cost. So, sometimes you have to go and deal with rules. So this is one point of view. This is more where I like to live. This is more modern. But so, dashboarding tool, you must have a dashboarding tool that can cut and slice your data and you end up with a few views that you like and that you show your executives all the time and that you live within. But the truth is, on a daily basis, somebody might come and say, what if, what about that? But I just wanted to show you, this is a neat one. I actually like this one a lot. It's something that people don't see a lot. This says, not started, in construction, in closeout, canceled. These are the number of projects by status. So you can see they have a lot of their projects, because this has happened late in this is produced for the plan, late in the plan. So a lot of the things are in, but not a lot are not started. We actually observed from this that they were actually not following some of their own rules. They were afraid to close out projects. Because for them, closing out a project meant that they couldn't obligate any more money to it. So you actually end up seeing some misbehavior in your own organization. And then I don't know what the financial people do. They don't close out any projects. How do I know if I'm going to need more money? So they ended up going through an effort to change our policy for how we close our projects. It actually affected their financial department to change their own policy because it was like, okay, that's great, but how much money is left? We need to know. It's real. But you need to have a dynamic dashboard. You could put different things on the board, and it's kind of like Excel could do, but just more powerful and tied into all this raw data. 37 minutes? Okay, good. So what do you get with all this? And what do we do? We talked about, I'm summing up. I'm doing the summary, tying things up. We did automatic project creation, very important. The thing I didn't say about automatic project creation is the cost of the project is different than the cost of the needs because of roll-ups. There's some organizations will end up showing the cost of the needs and make that the capital ask. And then once they do the projects, it will cost double. And then 2 years later, people say, why didn't you tell me 2 years ago it's going to cost double? So that's a big thing. If you get anything out of this, get the fact that the cost of your need and the cost of your project is not the same. So we deal with that by having two levels of costing. We build projects from bundled needs. We have multiple variables that we look at for prioritization and analysis. We're traceable to the field observation, and we can do scenarios. These are not unimportant things. How should I say? They're important. And the client really, this started 15 years ago, so they've really kind of, in their maturity, their budget has increased threefold in the 15 years that they're doing this. Mostly because they're in a political situation where if you have a better plan, you get more money. So a lot of other organizations can't articulate their capital need and don't get the money, and they can, and they're getting the money because the plan is so good. Not to be underestimated. Okay, let's talk about other integrations really quickly. We talked a little bit about CMMS. So your work orders can be used to help you prioritize. And some people do it non-automatically, and now if you have, it's a whole subject, but you saw one example with that 3D model where you had the work orders that you could start prioritizing. your space management systems. And I think about this in terms of kind of where are your important spaces, making sure you use the right names for things and stuff like that. The project management systems and the ERP systems we talked about a little bit previously. Other data that you would be thinking about integration. Roof thermographies, and also you could use facade thermographies. They're kind of cool. They're cheap, and they have a lot of data. Population studies and enrollment projections. Energy conservation measures. I mean, we just did a very big project with we were looking at 2,500 buildings, and about 20% of them, they did energy conservation studies on replacement of condition issues, but not in kind. In other words, I mean, the simplest one is go change your lighting to LED lightings on the fixture level, but there's other energy conservation measures, especially for boilers and stuff like that. BIM, we talked about a little bit. GIS, we talked about a little bit, especially for visualization. But you can also, if you have stuff that, if you have like gas pipelines running, stuff like that, GIS starts helping. Building automation systems, that's pretty new. Building automation systems are code for I have my thermostats or I have my temperature readings, and I can actually get my temperature readings in each room. And that information can be used. IoT, it's mostly in energy right now. It's the same kind of thing, the turning on and off of air conditionings and temperatures and stuff like that. There's more to it than that. You could have doors are starting to be IoT'd and a lot of other stuff. And traffic studies are also an input. If you have areas that have, it affects the doors, it affects the rooms, it affects the carpets. It also might affect how wide an area has to be. You start looking at flow. This is, especially in airports, this comes up a lot for us. That's my presentation.
We have about 3 minutes for questions. So.
Sure.
And we do facility condition assessments, and I happen to be a manager of multiple facilities for the Department of Veterans Affairs.
Mm-hmm.
So I'm unique to the group here, not really universities, but someone. And one of the things that we struggle with is that although we identify all of our priorities and identify our needs based on facility condition assessment, is it how do I hate to use the word penalize, but penalize one facility for not maintaining equipment versus another facility that does, because if they just wait till failure, they're going to get funding.
That's a policy issue. That's really my finding. That's really what we found. That some people purposely will not maintain because it will come from a different budget, right? So a system will not change that. You have to change your policy. You have to require them to maintain it at a certain level. So I think of that, you want to ask a little more? I can tell you what I think about that. I think you have to have a way of measuring their care and the care over time. So we call it a due diligence review, which it's very similar to a condition assessment. Do a condition assessment 2 years in a row and see if they've been able to maintain it at that level. Or the other thing is dive into how much money they're spending on their condition assessment, or make them pay for it out of that budget. This was set up. It was set up to fail, right? It's not the people that are doing it, it's the incentives that are doing it. So you have to fix it at the incentive level. Really, that's what it comes down to.
One of the inspections that you do help yield out who's behaving that way. You're talking about one of your first slides, we're talking about having your field inspector doing an inspection of assets.
Right.
That's really, so either they're doing the inspection of the asset correctly or they're not, and that would be a tracking tool to know.
Well, the issue goes beyond that, though. So even if they find that it's bad, let's say it's a 5 in our world, there's no incentive. We definitely come across this all the time. If they fix it, it will last longer, and it will come out of their budget. If they don't fix it, it will fail sooner, and it will come out of the capital budget, right? The luxury in this one is we were only dealing with the capital budget side, although we're talking to the other side as well, and they really care about their facilities. And really, it has to be something that comes at that collaboration. And when we find that a lot of organizations have created these 2 different sides. and I think that's where the solution really is going to come from. But really, at the end of the day, find a way to quantify the level of condition they're maintaining it at is the way that could come from this system. But otherwise, is look at their work orders. I mean, just you have to measure how much they're doing the maintenance. Really, some way. That's the only real way to solve that holistically.
I don't want to stop the competition because we're 10:15, so those that need to get ready to go. But I'm pretty sure Stephen more than welcome to stick around for those that want to have further dialogue. I don't want to stop the dialogue, but try to keep moving. Before you, for those that will be leaving, please go to your guidebook. There's a rating for each session, so please make sure the rating session. And those that want to be excused and those that want to stay for tea and dialogue with Stephen, feel free to. I'm just trying to keep those that need to move on to others. Please don't do so.
Sure. Sure.
How do you develop your cost estimate?
So that's a little bit of a complicated answer because there's two places we have cost. So one of them is we look at the PBSDAU, the physical breakdown structure, deficiency, action, unit of measure. So it's a pretty granular thing, and we try to put a unit cost on that when we look at labor, cost of materials, and other kind of cost, and end up with a unit cost. That drives the cost of the need.
And then how did you develop each one of those granular pieces?
So each one of them, we had cost estimators that look at things like RS means, look at local issues, and in some cases have to look at policy. So for instance, if you have a crack and you have a certain linear feet, you assume like if you were going to patch it, you were going to do 2 square foot to the side and patch it. Of course, many of these are not ever going to get addressed that way, but that's the way to determine the cost, the kind of the holistic cost of the need. So they assume like what it will actually require to fix that one thing in isolation, to take that action in isolation. So they look at RS means, they look at general labor costs, and we consider things like inflation and deterioration over time.
And I guess I was, that's kind of the way we do it, but.
But you only do it once for each unit cost.
Right, and I was thinking if you had a database, you could look and it would, estimate itself.
We do, but we built that.
Got it.
We built that, and it gets reviewed annually. Yeah, and that's really, because it's granular enough, I mean, there's 10,000 of them, and most of them only get updated for inflation on an annual basis, or let's say they find copper changed cost in a significant way, and we're able to update them for copper, or,
Sure.
stuff like that. So it doesn't, it actually, of this whole process, it's not, it doesn't really block the process in any way.
Is the project cost coming out of those same need costs? Or is it different?
It's a secondary, so that's a good, so the project cost takes, so this is what we do. We take all the costed actions that are going to packaged into a project. And we have some policy that says all these kind of things would be grouped. So let's say all the roof deficiencies that have been observed, we're going to do a roof project. Take all those, package them. We then add them all up. Then we have, from experience, policy, built-in policy that says, oh, we'll take the sum of those, and that will be construction cost. Or if we know it's influenced by other factors, let's say the type of building it is, we'll put some multiplier on that was developed through either regression analysis or through smart people. Then that will be the construction cost. Then we'll apply that chart that I showed you that will say, okay, from that, what will be the other costs, the CM costs? And then we put on that also kind of cost of money, like inflation, and then if you delay it, additional cost. I mean, that's in summary.
It's a series of business rules.
It's a series of business rules, but the business rules are refined based on statistical analysis, or more, now it's more like data science, that look at previous performance. Because we've doing this long enough, we've executed projects using the same methodology, so we kind of know what happens.
You can report back.
Right, so we actually say, our original estimating, the way we did it 15 years ago, produced numbers. They were off by 20% on average based on these parameters. So now we take all that knowledge and lay that on top of our rules. So we have kind of data science overlaid, because we have long enough, overlaid on what the rules came up with.
That's fantastic.
Yeah.
You mentioned that you need to analyze
analyze the past work orders to make a decision, right? But as you know, 80% of the work orders were not associated with a particular set of equipment. So I assume that leads to the question is how high quality of the work orders need to be what they need to link to, right?
Yeah, and you know what? The thing about it, and I know that you're a real expert in the BIM world, but so the real challenge is how do you map work orders to BIM? So what we've done is we said slim BIM, the simplest thing. So we analyze our work order, let's say Maximo. We've done this. This is actually Maximo data. We looked at Maximo data, we said, what do you have? You have room numbers? Okay. We made sure our BIM was good enough to have room numbers. We said, oh, we know it's a cabinet type deficiency. Okay, well, we care about cabinets, let's put the cabinets in the room. That's as far as we go. So then when we placed the cabinet work order, it actually exists somewhere, and it's good enough in space. So we were able to tell like the difference between a mold work order that was caused by a leak of the roof or by a mold work order that was caused by plumbing, because you could tell that it was in that area behind the bathroom that has all the pipes in that area that's not a room, right? What do they call that? I forget. The chase wall, right? So by identifying a chase wall, you don't really have to identify that much. If you know there's a chase wall, and you know there's something within a few XY coordinates of that chase wall, it's most likely a plumbing issue. And so you could evaluate. Now you combine that with your condition information, and you could really start saying what action you could take, and it's direct savings, because you know how much it costs to run those work orders over the last 3 years. And if you had just done that action 3 years ago, you would not have to do that, and it's going to get worse. So that's pretty cool. That's very new. Very new. Yeah. So, yeah, if I have.
I have a quick question.
Sure.
on integration.
Yeah.
So when the inspection is happening, is there an integration where there's stuff that you can directly submit a work order with your inspection sheet, as opposed to you do the assessment and then someone goes in our problem and someone does the assessment, they go in and then they key in all the work orders for operational items that can be fixed right away?
So let me understand the question. You're trying to understand how.
So
What's the essence of the question?
The tie-in at the end, that pulling in cumulatively how many work orders were put in with your slim BIM model.
Right.
But just what we find is, as someone's doing an assessment, I'm assessing this room, this light bulb could be changed right now. It doesn't need to be part of the bigger plan. So what ends up happening is there's the conditioned assessment for the capital plan, but there's also operational items that can be tied in.
I'll tell you how we deal with that. So we have an item called potential action. And if somebody puts maintenance in there, we assign it a cost of 0 for the capital plan. But you then just have a report that pulls them out. Now it's not, right, that's really it. We also, what we also do is if there's any emergency condition, they go and fill out a separate form, and it automatically emails the right person. So if you have a structural issue or some kind of priority condition, you say it, and you put out a separate form. I mean, we have other kind of things that we actually are in places that have a lot of crime. We have a threat of violence, actually, that people could go off. We load all of our violations, our local violations, and they get cross-referenced while they're out in the field. So if somebody sees something and they know that it's related, they'll see the list of violations, they could correlate it to it. So there's all these other little secondary things we do, but that's specifically how we deal with the maintenance. But we don't rely on those to do that analysis I showed you. We actually go to the work order system, because it's real, right? It's transactional. And the truth is, people are running Maximo for years now, right? They're running AssetWorks, whatever they're running, and they're not analyzing the data. I mean, some people who are smart, who have been at the building for a while, who are working on it, you'll get like smart people doing things. But there's no way, I mean, as soon as that person leaves and there's a new person, that's all lost, right? And it's not analytical in the data sense. So and it wasn't really possible until you had these slim BIMs, and they mostly don't exist for the old buildings. So a big part of it is convincing people that they could build these like reduced BIMs. Just for this purpose, not for all the other purposes.
Just one quick announcement, just be mindful that at 10:45, the Spark session starts for all the various business partners. So I'm not trying to start with you, but thank you, Stephen, for the presentation. conversation, and it seems like you do have a lot of interest, so like I said, feel free to continue to talk, I just want to make sure, everybody can get in, to see the Spark session at 10:45.
Great. If anybody wants to give me a business card, I'll call you back. We could show you more how we, kind of a deep dive in any one of these areas. Okay?
Thanks, Steve.
Thank you. It was a pleasure.